When I consult a server using my smartphone or website, what do the packets that arrive at my terminal pass through? That is the question we will answer in this video. The Internet network itself cannot manage mobility. Each packet is intended for an address, and an address is generally linked to a physical location. The solution adopted for 4G networks was to converge packets destined for mobile subscribers to a single network gateway called the P gateway or packet gateway. That means that when I consult a server, the packet constituting, for example, a piece of website will be transmitted through the internet to my mobile operator P gateway. Then, from the P gateway to the base station using the mobile operator's own IP network, and from the base station to my terminal over the radio channel. So, the function of the P gateway is to route data to the terminal and also to take care of a certain number of security functions. It's a gateway and it must be protected against attacks from outside. In the opposite direction, when I send a request from my smartphone, it's the same thing. From the terminal to the eNode B, from the eNode B to the P gateway, from the P gateway to the server. If we have a network with a large number of subscribers, like in China, there can be several P gateways because one P gateway does not have enough capacity to manage all packets. Several P gateways can also be necessary to have redundancy and ensure reliability. However, P gateways are always limited in number. If you think about it for a second, the typical number of eNode Bs for a French network is around 10,000. In certain cases, in dense areas, the coverage of an eNode B is just several hundred meters around that eNode B. On the other hand, there are just a few P gateways in 4G network. If we consider the transfer to a terminal, when this terminal is moving, we can see that we'll have to notify the P gateway and route data not to the former eNode B where the subscriber was before, but to the new eNode B. This rerouting requires the exchange of signaling messages to avoid frequent rerouting at the level of the P gateway. We'll introduce intermediary equipment called the serving gateway. The serving gateway serves a given geographic zone, typically one French region. Now, we have an additional hop. Server P gateway S gateway eNode B. That seems slightly more complex, but the advantage is that when the terminal moves, very often it remains under the same S gateway, and that it's only the S gateway that has to manage this mobility, this rerouting. So, an S gateway enables not only the collection of data sent by the mobile terminals to various eNode B, but also the distribution of data coming from servers to the eNode B where the terminal is, which is what we represented here. The serving gateway and the packet gateway are two very important elements of the core of the 4G network. Something to note is that the packets that make up the data stream, for example, the video stream I look at on my smartphone, go through the P gateway, it's the entrance, and the serving gateway, which is linked to the place, the region where I'm located.